Hands? See 5. Who thinks they're bad? Yeah. It's kind of depressing that we have so many PhDs solving problems in Haskell, solving the most advanced type theory, and yet somehow we've managed to live with records that are universally hated for decades. So these are just some comments that people have made about Haskell records. So I just Googled Haskell records suck and omitted a few with profanity and got the top 5 or 6. So we can say, an in-your-face glaring weakness telling you there is something wrong with Haskell. The record system is a continual source of pain. I mean, this is not how we should be. So this is Haskell, but no other language really complains about their record syntax. So in some other languages, if you have a value of a record type, say my person, which is the record of persons, or the struct, or the class, whatever you want to call it, and then type .name, that gives you the name of the person. So which language is this? BlueSpec. Call out names. Elm, JavaScript, OCaml, Rust, Go, Java, C++, Ada, Perl, every language, Python. What language is it not? Haskell, and I think it's not Lisp, but I don't know for sure. It's a really small subset. Assembly, white space, but you're having to get pretty esoteric pretty quickly. But this could be Haskell. How can it be Haskell? Well, if you use the record.preprocessor library for Haskell, that's both a textual preprocessor that makes this syntax work and a GHC source plugin that makes this syntax work. Or you can use DAML, which is a Haskell derivative, very, very similar to Haskell, but with this working, basically because it uses the record.preprocessor as a GHC plugin. Or, as of this morning, if the latest GHC proposal gets accepted, this will be Haskell too. And if you want to go and spam it with upvotes on the thing, tinyurl.com GHC records. Or just go to the GHC proposals website. So, I love questions. I love an interactive talk. But in this talk, and I think this is the first time I've ever done this, no questions on this topic until I enable it sometime later. If you don't know what topic I'm talking about, that's fine. You're probably not going to come up with these questions. So, what do I want to do with a Haskell record? So if we think back to the original Scrap Your Boilerplate paper, it defines a data type of company and a data type of person. And then it says, well, companies are owned by people, they employ people, all this kind of stuff. So we can create a very basic Haskell data type, company, that contains the name of the company. So, pick your company, Google or something. The owner is a person. So this is the person who owns the company. And also a person, which has a name and an age. So what do we do when we type in this definition into Haskell? Compile error, multiple declarations of name. And so, yes, I have got name here. People have names. Companies have names. But why did GHC say multiple declarations of name? What about Haskell means that this doesn't work? Anyone know? Record type. So the specific issue is that when I type out this, GHC very helpfully produces this. So it produces a nice little function called name that, given the company, gets the string associated with the company name, and given the company gets owner, given the company gets the person. So it generates all these helpful functions, but unfortunately, name takes a company to a string and a person to a string, and now multiple declarations of name makes perfect sense. So I can't do that today, which makes me very sad. So what do I actually do? How would I actually go about solving this problem today in Haskell? Well, one thing I can do is make all the record field names unique. So in company, I don't have name and owner. I have company name and company owner. And in truth, no one actually spells out company name and company owner. They write something like or per name. So you get these ridiculous abbreviations to be basically a kind of locally unique name spacing on your fields. And then when I want to get the name of the owner of a company, I do person name of company owner of X. So it's quite verbose compared to what it would be in most languages, and I've had to repeat the information, and I've had to guess at the vowelless abbreviation people have used. So who has used this style when trying to get around the fact that records are not very good? Okay, that seems universally popular. So there's another technique you can use. You can use the name field twice, but then put them in different modules, because modules can have overlapping names. And then basically you end up needing to create a module per record, and when you want to use them, you import them qualified. So you can say, well, company, let's call this C as my prefix, and now I can do p.name of c.owner. So this is a technique I've seen advocated in some big companies I've worked at, where this prefixing technique is a bit too monotonous in some cases. So who's used this technique to work around poor records? So about half the number of people who've used the other technique. So obviously the first one is the most popular. But actually, this is the real technique I use. I just cry. So you explain Haskell to a beginner, and you say, well, you've been programming Haskell all your life, you just didn't know it. It's just a very direct, you write things, functions are in terms of functions, you describe things by breaking things down into smaller pieces. It's all beautiful. Oh, apart from the records, just retype all the types there. You never need to write your types. We can always infer them. Apart from the field names in records, where you better write the type name concatenated with the string you want to use. And then I explain Haskell to experts. I was talking about Haskell with an expert in many programming languages just on Tuesday, and he described Haskell to me as that one where records are broken. This is a sad state of affairs, trying to convince the rest of the world, the C programmers, the Python programmers, to come and embrace Haskell. So, what's the solution? The record.syntax extension. And using the record.syntax extension, you write exactly what we had initially, and for those of you who are in the back and can't see this, x.owner.name. It's exactly what we want to write. It's how every other language on Earth works. And now with Haskell, we can have that. So that's the solution. And for the rest of this talk, I'm going to explain how that's implemented and what we get from it now we've implemented it. Any questions so far? Other than how is it implemented or what do we do with it? But yeah.
How does it work with the composition? Because right now this would be a function composition, right?
Indeed. So the rule we created was if there's no space after the dot, so you can still have composition, but it's got to be x space owner, which is how everyone, apart from one particular sub-community who shall not be named, already write composition.
With this syntax, do you still get the function, like a function called name, which goes from company to string?
Great question. Ask me again in 3 slides' time. Cool? OK, so before we go on, I'd like to say this change is a big deal. So the context here is DAML is a programming language for smart contracts, distributed ledger, that type of stuff, developed by Digital Asset. And they wanted to move from a language that looked a lot like Haskell to one that used GHC as its base for implementation. And the biggest thing stopping them, I was working there at the time, so the biggest thing stopping me was the fact that Haskell records suck. And if you're defining things for like the domain of finance, saying you can't have 2 records which have currency as a field It's just a non-starter. So until we figured out this, we couldn't do it. 18 months ago, we figured out this whole thing that I'm going to describe in the talk, and then we moved to Haskell, and so for 18 months, this has been in production with very happy users, and no one has said anything bad about it. This is just how everyone expects it to work. So I think that's a great sign that this may be the solution. So how does it actually work under the hood? So the first thing is don't generate those selectors. The problem with writing the field names having two names was the name selectors clash. So let's not do that. And that's already part of the no field selectors proposal that's already been accepted in GHC and implemented and turns up to clean up a bunch of the code in GHC. So that's probably how it should have always been. But now, how do I get the fields? What do I do to get the name of the owner of a company? Well, I can just write this beautiful case expression here, which is basically case X of company, curly brace, owner. So this is some record punning syntax that says match on the company data type and grab the owner field out as a variable. So I haven't actually used the owner selection function. I've used matching instead. And so instead of what I'm hoping to write x.owner.name, I can just write this 3-line case expression. So that's correct semantically. So all we now need to do is sugar that up. So one way to sugar up case on some expression of some constructor, some pattern name, arrow, that pattern name, would be, let's hypothetically pick a.b.c. So we could write our whole expression as x.company.owner.person.name. Actually, if you think about the two hacks we've employed to get around this, this is exactly what we do today. Apart from, in one of them, we concatenate company and owner together, and in the other, we use a qualified name, a module name here. So this isn't too surprising that this is the hack we came up with, because this naturally falls out. But, of course, it's super ugly. We've said x, which is of type company, dot owner, dot person, having known x.owner as a person. So we've duplicated the types in a way that was completely redundant. So can we do better? Can we get rid of the type level information? So, sure, we could try sugaring it up. So x.owner.name uses, under the hood, a.b is get field ab. So if we kind of take that approach, where would we get to? Well, we'd have to write a function get field that takes a record, so the A, the string, so the B thing we're looking for, and returns some type level function of the record and the string. And Haskell has lots of ways of doing type level functions. So you've got type families, GADTs, functional dependencies, and I'm sure someone will have proposed at least one new form of type level function during this conference. So we can compute a kind of the type of the result of, say, x.owner here, but we can't compute at the type level on a string without a dependently typed language like Agda or Idris. So what can we do to bring our string up to the type level? Well, so Haskell has this feature called labels. So if I write quote b quote, that's a value of type string. And I can't compute on that at the type level. But if instead I write at quote b quote, that's a label, that's a type of kind label. I'm going to be fairly informal about the dependent type business here. So essentially I've said, take that string b, lift it up one level, and now I can write my function on the record and the label. So how does that actually work? This. It's not super complicated, so I'm going to go through it, but if you don't follow the details, don't worry too much. So in GHC already today, as of, I think, a few years ago, there is a class hasField that, given a label name, a record, and the result, the field that that label points at, gives you a get field, so it gives you something to get from the record to the A. And there is also a functional dependency, XRA, that basically says, given a record and the field you're talking about, you should be able to know the type of the value in advance without having to guess the type of the value. And so there's also an extension in GHC that means that when GHC wants one of these instances, it will manufacture one out of thin air. So GHC will automatically write something a bit like this for all your code. So for hasfield, person, name, string, it just writes out the record pun for you. So GHC automatically generates all this, and then if we say x.owner.name is just get field type level string owner, x, and then get field type level string name, we have x.owner.name just working. So, let me just pause here to appreciate the magic. Records were completely bust in Haskell, and we have managed to fix them by combining 4 pretty simple things. Don't generate the field selectors. That's basically doing less work. A hasfield type class. That was 2 lines. Automatic instances. That was maybe 100 lines. And some minor syntactic sugar, which is maybe another 10 lines. So with a few hundred lines of Haskell, we've managed to fix records. Any questions? What do compiler errors look like? At the moment, in something like DAML, we desugar the dot to get field, and then present you error messages in terms of get field, and they haven't been a problem for anyone. Once it was baked into the compiler error messages should look perfect. It should even be able to say, X is of type person, and it has these fields on it. You should have, you've typoed this field name. So they should be really good, and you should be able to get auto-completion for them. Should be even nicer.
So when we say records are broken, we don't mean that only getters are broken, right? We also mean that a lot of other things about them are broken, but this only solves getters, but nothing else.
Excellent question, Roman. I have so you'll notice I'm asking for questions at the 20-minute mark. There's a whole 20 more minutes about updates, so we'll go there now. So another thing you can do with this technique is have pairs of labels as a whole, as their own entity. So I could define a hasfield instance where you had a pair of type level strings. So we can start writing things like get field at owner name x instead of doing the 2 compositions. That looks nice. And do you have a question for me? No. The question was, what if we wanted to actually use the selector? Which was a great question. Well, we can write open brackets dot name, close bracket. So in Haskell, it generates the name, which is a very useful selector. So we can write map name people. In the new world, we can write map open brackets dot name people, which is just syntactic sugar for get of at name, get field of at name. So we can have everything we had before. Slight syntactic complexity here, but it's totally worth it. Now, the second half of the talk is essentially, how do we do this for record updates? And the answer is nothing special. It's fairly vanilla to just apply the same techniques to record updates, but we can even reuse the existing syntax. So, firstly, how do we make them work? So in general, a record update, A, B equals C, with this funny curly brace, says, take the A expression and give me a new expression, but where the B field is replaced by the C value. So, as before, it's no massive shock that we might want to desugar that as set field with the B in quotes at the type level, and then the A and the C. And as before, we had a set field. Well, set field took an R to an A, so project out the thing inside. Set field takes an R, and the new A you want to replace it with to an R. Nice and easy. And if you have multiple field updates, so if you set B equals C and D equals E, then you can just do multiple set fields, one after another. All nice and easy. Does anyone know where I cheated? What? So we have this, and it doesn't work. We have record updates, and they don't work if you have duplicate names. This is just saying, well, we have record updates, now make them work in the case of duplicate names. But I actually cheated. Polymorphic updates. So actually, that's not the type of updates in Haskell. If I define a data type that is polymorphic and a field that is polymorphic, I'm allowed to write this monstrosity that says, given an x of type fooint, update the field foo to a Boolean, a list of Boolean, and now I have a foo bool. So my updates are actually allowed to change the type as they go through. And this is called polymorphic updates. And who knew polymorphic updates were a thing? OK, that's quite high. We must have a lot of Haskell implementers in the room, because it's never Haskell users who know polymorphic updates exist. So really, we can still apply the same trick. So set field now needs to take a label, type level label. I said I was being very hand-wavy with the dependent type stuff, and an R and a V, and produce some kind of function over the label, the R, and the V. OK, so we can push that through and do exactly the same trick, but suddenly the type inference starts to fall down pretty badly. So before, I said, we could desugar this into multiple set field calls, and we can still do that. But if you remember, the set field says, if I absolutely totally know the type of the record, I can give you all the other good stuff, and absolutely totally know the type of the field. And that's easy. Now, after applying set field, if I use the empty list, now this has type foo A, but what's the set field instance for foo A? How do I find it? So I can do horrible tricks like pushing the instance context to the left and using a type equality on the left of the implication that GHC will see through and then resolve. Or I could try a type function and make sure I get all the right pieces in the right place. So there are some slightly complicated solutions to this. But actually, no one uses polymorphic updates, so we can just delete the entire feature, and no one's really going to be sad. Does someone here want to claim they would use polymorphic updates? Roman has 2 hands, so no one that matters. The other thing is that polymorphic updates are trivially emulated with this syntax, so pull apart the record foo, and then reconstruct the record foo, just shoving all of the things into the local namespace in between. So it's hard to care about polymorphic updates if this is what you have to do for the odd time they matter. So I hope when Roman said, what about record updates, he was also referring to the fact that they suck in many other ways. So far, we've solved the problem that if there are 2 names in scope, they now work, but they do still suck. In particular, if I want to change the owner's age to 42, I have to write some monstrosity like this. So get the owner, change the age to the 42, and then change the owner in X to this new owner. So that's horrible. But what's worse is if I was to try and change like 1 level deeper, it gets even worse, incalculably worse. I think it might even grow n squared if you follow this pattern. So I would almost certainly have to write a function for changing the owner's age in a company, in a conglomerate, in a stock exchange, or whatever. So I've repeated owner twice, and yeah, this isn't going to work. And this is what we've got today, where it doesn't really work. But we can fix this. We can just say x owner.age equals 42. And if you remember, I kind of gave you the curiosity that we can do tuples of labels for a get field. Well, we can do exactly the same for a has field, for a modify field, for a set field. And now we can just say set field at owner, age, x 42, as the desugaring of this. So now we can deeply update in records in a kind of easy, simple, natural, expected way. So I kind of feel like with what we had so far, we got Haskell to as good as other languages. And now we're starting to go past where other languages can go. Of course, in other languages, you just use a mutable variable, and this would be a mutation. But in Haskell, this is still a kind of change and update as you go. So it's still very nice. So anyone know any other problems in records? Record updates? Updating multiple fields? Well, so this syntax extends to updating multiple fields. You can just comma, comma, comma. It may mean something slightly different, because if you put comma owner equals me, then this update of the owner's age wouldn't actually have had any effect, whereas if you change the order, it does. So there's some slight syntactic tweaks there, but semantic tweaks rather. Of course, the other thing is often, how many times does your age change to 42? Only once. Whereas regularly, people's ages increment. So what if we try to increment someone's age? Well, we can say x.owner.age equals x.owner.age plus 1. So that's not terrible. Without the nested record update, it would have been, but now it's not terrible. But I think we can do better. So in the record.syntax, we propose adding this syntax for modify owner.age by 1. So we can write owner.age plus 1. You may wonder why not plus equals 1, which might be the slightly more C way of doing it. But the problem is, of course, in Haskell, you can have the plus equals operator, and you really don't want to change that to plus equals equals. And we can desugar this very nicely to modify field at owner, age plus 1. Does that seem good? Question? Yes. So what can go after this? Yeah, a general section. So any operator. So it could be tick, div, tick, 5. It could be plus 5. It can be other things. And in particular, who knows the ampersand function? Yeah, it's catching on. It's basically the flip of $, which means you can now write any function you want as the updater. So if you really decide that this is the way you should change someone's age, so multiplying it by 52, rooting it and adding 21 and then flooring that, you can write that in nice and simply, just using the ampersand operator here as the section you want to apply to the record field. And yeah, it just follows the exact same desugaring. So, is modify field expensive? Well, you might think the natural way to write modify field was a get field, applying the function f, and then a set field. And that's a perfectly correct definition, but some people worry that this would be expensive. Personally, no. I mean, you're traversing the field names twice, but GHC is a really good compiler, and I'm sure they would sort it out for you. But some people worried. So what can we do instead? Well, instead of having get field and set field in our has field type class, we can have just a single method has field that, given a value, given a value and implicitly with the x, a selector and field name within it, gives me the value at that selector and a function to replace that selector. And you see this idea come up in loads and loads of things, including this thing. And now we can write our modify field in terms of a single has field. And so we only traverse the structure once. We only deconstruct the pattern once. So whenever you introduce has field, there are 3 questions, one of which is verboten at the moment. The first is, can you define your own has field instance? And the answer is, yes, you can. GHC allows this. So if you want to say, well, my data type contains the temperature in Kelvin as a field, you can also pretend it has a virtual field which contains the temperature in centigrade and in Fahrenheit. You could also use it for compatibility, say if you rename a field or add a new field or some logical field as a composition of other fields. So yes, you can do all that, and it's quite nice. What I would ask, though, is can we please not define one for map, because that's really not what this is meant to be used for. But I'm sure someone's going to. The other worry is, well, actually, Haskell has this great mechanism for defining a data type with fields in it, and then not exporting the internals of those fields, and not exporting the field names, so that the structure becomes encapsulated and abstract. On the other hand, Haskell instances, they get everywhere. If you write them, they will get to every consumer of your code at any level. So if Haskell instances for hasField did exactly the same, you could modify internal details just by guessing their field name. And that would destroy any invariance you want to preserve. The great thing about hasField, though, is it's implemented specially, so it isn't a real instance, but when GHC wants the instance, if it has the selector in scope, so you could have modified it anyway, it then manufactures the hasField instance there and doesn't export it further. So this way, you can keep encapsulation and use hasField. Any other hasField FAQs?
Yeah, it's similar to the first question. So I thought of, is it possible to write something like a string, hello world, dot length?
Is it possible to write that? Yeah, well, so how do you set the length of a string?
No, you don't.
Exactly. So yes, you could write it. You might have to write an updater that returns an error. Or some people have asked for the separation of hasField into a getter and a setter subclass. If that happened, you could do that.
So let's assume you have like a field which is like exported. So you automatically get the hasField instance. Can you like redefine that and like use some overlappable magic to use your own stuff?
I have no idea. Do you want to? No. we have the hasField author in the audience. There's another one.
How would all of that work for some types? If I have something like animal and I have a dog with a name and a cat with a name?
I would recommend not using record syntax on some types. It doesn't go well. In truth, I'm not really sure what it does. Probably throws an exception. Yeah? Yeah, so Adam says it's the same as the selector function. So yeah, you get a runtime error, which would be deeply unpleasant. Not solving everything about records. Okay.
So the x braces owner.h+1 thing, what exactly is it strict in?
What is it strict in?
In particular, is it strict in owner and is it strict in age?
So owner and age are source level constants that are lifted to the type. So yes, it's strict in them, but because they're types. I think Roman has it.
I mean, in the fields, is it strict in the owner field of x? Is it strict in the age field of the owner field of x?
Probably. I have no idea. Whatever the desugaring implies, I think. Yeah, I think. Cool. I'll move on. So maybe I'm not the first person who told you that records have been solved. So there was a whole extension called duplicate record fields that got created and is in Haskell and is super complicated. And with that, you can write name, owner C, : person. And the fact the name is duplicated doesn't cause any problems. It just picks the right name. So the problem with this extension is that the argument to name must be a locally known type, which even GHC's manual is fuzzy on what that really, really means, which means that this works, this doesn't work because you've given a type to the company, not the owner, and this doesn't work because the type is on the left of the equal rather than the right of the equal. But if I put it as a type signature, it works. So anyway, there's this. We took a look at it for DAML, but decided I get confused by what works and what doesn't. Our users would also get confused by what works and what doesn't. But the fact that people put a lot of effort into engineering this suggests it's a real problem. So, prohibition lifted. This is a lot like lenses. I think we can all agree, especially once you see the has field. That is the traditional encoding of lenses before we came to the Van Lohen representation. So there is absolutely definitely overlap. And what's worse, the lens people, and only the lens people, like writing C hat dot company owner dot person name as their way of composing record selectors. So if you have lens code, the chances that you're putting no spaces either side of your dot are vastly higher than if you don't have lens code. So yeah, it pretty much conflicts with the lens style. So you're probably not able to use it with most lens code. But when I think of it, I think of kind of, lenses are the value level and highly abstracted over getters, setters, traversal version of record fields. So it's really super cool that we have the abstract in this direction, value level version of records in Haskell. But those two axes of complexity really cause a lot of complexity for when you're not using the power that lens gives you. So it's really like we did all the clever stuff, but forgot to go back and do concrete, simple, basic records. And yes, you can use the powerful stuff to do them, but it's a more painful experience. Heavy lens users probably won't want to use record.syntax. People who shy away from lenses can use this, and then start to use lenses for the more powerful thing. The other thing is, if we think back to the original motivation behind behind this whole work, it was for DAML. So the idea of DAML was to give a very smooth beginner experience for Haskell. So this is the DAML learning slope, hopefully. So it has things like a nice IDE. It has things like a redesigned base library which doesn't have overloaded numerics so that you don't fall in some of those pitfalls. It has a lot of simplifications to make the common path easy. If we'd said, well, and you should use lens to do your records, we would have come across this terrain. So this isn't my diagram. This is famous on the internet. That basically shows that those who try to learn lenses don't always have the greatest time with it. Finally, if you really want, so these are from the proposal. I'm not going to go through these, but these are just some of the aliases that the proposal defines. I think I've talked about all of these in the talk, apart from this final one, but it's not very interesting, this one. So you can see we haven't really defined that much syntactic sugar, maybe 5-6 lines worth of it. And then once you've got these things, they start to interact in slightly interesting ways, but not very interesting ways. So here are all the ways they combine with everything else. But finally, I'd like to leave you with the thought, we should have myperson.name in Haskell. And if the GHC proposal gets accepted, it is coming to a GHC near you. I'd also like to leave by thanking everyone else who helped this. Several of whom are in the audience. I see Adam Gundry and Matthew both in the audience. Adam's done all the original Hasfield stuff. Matthew had the original discussion with me that sparked this idea. The DAML team, especially Shane Fletcher, who's been writing it, and Simon Hafner, who did the record no selectors. So it's a team effort, but we've got there in the end, and hopefully we can get it into GHC soon. Thank you.
Great stuff, Neil. Got a few minutes for questions. I see one at the back.
Hi, that's really nice work. I was wondering, are you going to split the proposals apart at all? Because even just having getters would be amazing, and it would be such a shame to lose that if people don't like the modify syntax or something, for example?
Yeah, I did wonder about that, actually. So my thoughts are, if you've got the getters, then you've got duplicate names, and then you pretty much need to have the setters just so the program still works. This syntax kind of gets you back to where you were before, but certainly this line would be a reasonable proposal one, and then you could do this. Because of how human psychology it works, it's better to propose 7 things to someone and then meet in the middle at this line. So, we'll see what happens. I think they're all valuable, but if we stopped here, I'd be super happy to.
Cool. Good luck.
Thank you.
Given the overlap with lenses, why did you not choose to desugar direct to lenses rather than having the special has field and set field?
I guess I would say if we were going to do that, we would have made has field. So has field has the GHC magic in it. Lenses doesn't have any GHC magic in it. You could have said that, well, the has field should be a Van Lohen lens, and then lens could use the has field mechanism as well. As it is, the lens people weren't keen to do that unless they had the type changing updates as well, which then complicates the thing further. It's not unreasonable that you can find some overlapping ground. Certainly the first version of this that I did, the record preprocessor, did desugar to lenses. So there is ways to bring them more together. This was kind of like simplifying this in one direction, and you could still generate lenses from a has field, which I would hope they might one day do.
So to what extent do you sort of see this replacing records as they are in Haskell? In particular because there are some things you can't do with this approach, like record fields with high rank types, for example.
I guess I would envisage it mostly replacing it. Record fields with high rank types? How do you mean?
So if you have a record field whose type is polymorphic, like you've got a field of type for all A, AROA, for example, then you can't generate a Haskell instance for that because it would be impredicative.
Yeah, maybe someone should solve impredictivity.
So my concern is that you can sort of imagine a situation where you can use this in some cases, but not all. And then do you retain the existing record selectors for those other cases, or do you just kind of have to use explicit cases or something?
I guess I would suggest, I would say that those cases it can't deal with are really, really quite small, and I would choose to use explicit cases for them, which are fairly rare, but stick with this for most of the time.
Okay, maybe time for one more. Sorry.
A few hopefully quick questions. So just to check my understanding, so are you proposing to remove polymorphic record update from the language?
When you have this extension turned on, yes.
And there's disambiguate record fields and there's duplicate record fields.
I would remove all that mess.
And so this would just strip all that out, deprecate it, move on.
Yeah.
Thank you.
Yeah, sure.
So I think my question was made obsolete, but it really was to say that it seemed to me that there was a way to integrate lenses using Hasfield, which I think you have already answered.
Yeah, no, I agree. I think it would be valuable. Yeah.
Okay, that's us. A big round of applause for Neil. Thank you.
Thank you.